Okay, now we are beginning to see the house start to take shape a little bit from the initial block out. And what may seem a little bit complex and starting to get detailed at first, really it's quite simple. And I will show you the breakdown here, starting off with the foundation at the bottom. Now, at first, this piece might seem like I have quite a bit going on with all of these stones sticking out, but in reality, this is super simple. All I have here is a plane with a basic texture on it, and that is because I am using displacement to get all of this extra detail. Now, most video game engines are going to give you the ability to do displacement in the engine, but I try to steer clear from that, steer clear from doing displacement in video game engines, because when you are building out a level, one of the first things that is going to get optimized down when you get into the optimization stage is displacement. The engineers or the designers will come to you and say, we got to turn off all the displacement. There's too many polygons. We're putting too much load on the renderer to do all of this polygon division on the fly. Therefore, displacement usually gets cut very early on in the optimization phase. So to compensate for that, I pre-displace my assets in Blender, and that can be done very easily just with a displacement modifier. It's just in the modifier stack. You can add the modifier and then put in displacement, set your coordinates to UV so that it follows your UV map, and then input a texture. In this case, this is a Megascans stone texture, super basic. I didn't do any modifications. All I'm doing here is just controlling the strength. I can make it small or large. In this case, I found that 0.3 looks quite good. And then I also put in a subdivision modifier so I can control the level of polygons quickly. I have this at 5 right now, which I think looks fine, but if I wanted this to be lower res, I can put in 2. But of course, my displacement is going to look worse. So balancing the subdivision displacement is going to be an important factor to take into an account when you're doing things like these stone foundations. And then in UVs, what I have here is also rather basic, just a simple unwrap. And then by moving around my UVs, I can change the stone. I can increase the sizes with the scaling of the UVs. I have a lot of control here in a very quick and easy manner. The only thing that's really complex, the only thing that really takes some amount of thinking here is just how you subdivide your base mesh. If I turn off subdivision and displace, you'll see that all of these polygons are perfect squares, and that is just so that I get even subdivision across the board. I don't want something like this, where I have a bunch of extra polygons in one spot, where this one section is getting extra resolution when the subdivision pass happens. So even topology, very important. And then when I want to send this into my DCC, or rather when I want to take this from my DCC like Blender and send it to the engine, all I need to do is apply my modifiers, and then I have a mesh that I can send directly, or perhaps add a decimate modifier on, and then begin to chip away at the resolution. I can maybe set this to like a 0.1, and I'll go from, what was this before, like 86,000 faces down to 16K, and it looks pretty close. So using the decimate is a great way to get some of that resolution back on these displaced meshes. I'm also using displacement for the roof as well to get nice extrusions and deformation on my roof. This will look quite good when the light is hitting it in engine. And this is the same exact process for the foundation, with the only difference being that I'm plugging a different texture into the displacement stack, and this one's also from Megascans. Now with elements like the column here, I have some interesting things going on. Notably, it is aligned, the top of this column here is aligned to one of my phi scale divisions, which is very good. I want that to happen so that we know the column is in proportion with the rest of our house, right? The phi scale is governing all of these extrusions and locations of elements across the whole building. But I'm also using another element to control the proportioning of this column, and that is the Corinthian order from classical architecture. So when I look at columns, these ones, for instance, you'll notice that these are all the archetypical classical columns of architecture, and they each not only have different capitals at the top, but they have different widths. Some are fatter than others. So the Corinthian and Composite are quite skinny, and then the Tuscan and Doric are fatter, and then the Ionic is somewhere in the middle. And that is because they all have different ratios between the diameter of the column and its height. With a Corinthian and Composite, that is going to be 10 diameters of the column equal the height of the column. Ionic is 9, Doric is 8, and Tuscan is 7. So in my instance, because Victorian is usually more vertical and doesn't really care so much about feeling weighty at the bottom, Victorian always wants to feel more thin. I want to go with a Corinthian or a Composite here. So I want my diameter of the column to be used to get the height of the column. And in that case, that number would be 10. So if I take this circle, for instance, I already set it previously to be the diameter of this column, you'll find that this circle lines up perfectly with the diameter of the column in orthographic view. Now, what I can do from there is take the column, rather take this circle, take the diameter, rotate it 90 degrees and set it to be at set the bottom point of the circle to be at the base of my column. And then I just want to array that with a relative offset of 1 and the z-axis to be basically 10 counts of this diameter. And it near perfectly matches the height of my architrave element here. And it doesn't line up perfectly just because I scaled it down just a little bit so I can get other elements to align, which I'll speak about shortly in a second here. But the main idea is that 10 diameters is roughly giving me the height of my column. And then we also have the other element where the base here, this darker part of the column, is 1/2 the diameter. I can take a square and set its length and width to the diameter of a circle, rotate it in, and then in orthographic, cut it in half just with inserting an edge loop, and Blender will automatically insert the edge loop at the exact halfway point. And then I'm going to delete the upper face, and you will find that this piece near perfectly matches the height of the base. Now it's fine if this piece above sticks up. Above, this part is called the kanji, and it is known for being above and not being taken into account of the base of the column. And this kanji element is there just so that we can have a nice natural transition from the shaft of the column down into the base. So now we have the capital of the column, the piece at the very top. And with most orders, like Ionic and Doric and Tuscan, the capital of the column is going to be 1/2 the diameter. But with Corinthian Composite, you have a taller capital, and that is 7/6 the diameter. So to find that, I simply take a square that is set to the diameter, and I divide it with the insert edge loop tool into 6 parts, which basically is 5 cuts, right? So 5 cuts will give us 6 parts. So we can test that 6 pieces. And I'm going to take one of these pieces, duplicate it, put it at the top, and now I have 7/6 the diameter. And I will pull this to the top. And what I'm getting is a near perfect, well, I'm a little bit off because I scaled things a bit, but near perfect height of the bottom of my capital, right above this piece here, which is called the astragal. That should be 7/6 diameter below the architrave, which is this beam component above. And what is happening here is I am getting a proportioned capital piece. But you'll notice that this one is still a little bit taller, and that is by design. With the Victorian vernacular, a lot of the designers started breaking more and more from classical rules, and they started getting more abstract in what they were creating. So with this column capital, we are getting a piece that is taller than the traditional 760 Corinthian top. So this capital comes from a pattern book, and I have a picture of it here. This is a 100-year-old design, basically just a floral motif or foliate motif where you have ferns and foxtails in the design of this piece. And I quite like it because I also think that you could also look at this capital and imagine like tentacles or something more squid-like, which is quite fun. So I went with this design. And when I built it out, I set it to basically be built out of foliate pieces on a 45-degree plane of symmetry. And what I mean by that is when I take each of these individual components here, they are rather basic, right? I'm going to turn off all my mirror modifiers and show you that all I have here is a curved piece rotated 45 degrees. And then I use a plane rotated 45 degrees as the point of symmetry for a mirror operation. So just turning this mirror operation on, you'll see that Blender automatically bisects this piece and gives me a full component upon the 45-degree axis. And I do the same thing for all these other elements. These scrolls, same exact thing. And then I just use mirrors to give me basic symmetry for the bottom and for the top. So with these Corinthian column capitals, you are always going to find that they are built this way with the 45-degree angles. And that is because they need to reach the top, this part here, which is called the abacus. These points need to line up with the abacus, which fits into a square. With this design, again, because it's the Victorian vernacular, they're doing things a little bit differently. This one has a circular abacus at the top, so I put that in here too. And then I left this square abacus for my pilasters. And a pilaster is basically the part of a column that is squared out and then is embedded into a wall to reference the concept of a column holding up a beam above. But generally, pilasters aren't always structural. They are decorative to inform the idea that they could be structure. In this case here, I'm using these pilaster pieces next to the doorway. And I'm also doing something a little bit differently than with the column. And that is the way in which the pilaster climbs. If I look at this in orthographic, you'll see that the pilaster goes straight up. It is a near vertical climb without any deviation from a 90-degree angle with the ground plane. Meanwhile, if I look at a column, I get some distortion towards the top. The top of my column is actually 5/6 the diameter, and the bottom is 1 diameter. And this is called entasis, where 1/3 up the column, right? This edge loop here is the 1/3 point. I begin to diminish the diameter of the column so that I get this nice rounding aesthetic to the column. And this comes from the classical rules. Though, of course, with the Queen Anne here, they are not slavishly following a lot of those rules in the way that if you were to go to a city like New York or London or Barcelona and then measure buildings, you'll find that the architects of those more classical and Beaux Arts buildings, those ones will near perfectly follow the rules set up by Vitruvius and then later the Italian Renaissance architects. Whereas Queen Anne vernacular here, because it was kind of this style built up by builders and architects alike, they break rules a little bit more. And what you'll find with the influence of classical is that it's just there to guide the architects into making decisions as opposed to being something that they have to perfectly follow. And for me, I basically tried to do the same thing. I used these 10 diameters to get me the general height of the column, but then at the same time, I used the phi scale to overall order my main ideas here. And then additionally, I tried to get the center of this spiral, which is called the volute. I tried to make this pretty closely align with my phi scale division. It's not perfect, but it's pretty close. And then I also pushed the abacus of the column up a little bit into my architrave here as a way to kind of tie everything together and make something that feels harmonious. Now, also, in regards to proportioning, I used the pentagonal pentagram to order my doorway. So these 5 divisions mark the points at which the door connects with the door surround and the door frame. We also have the pentagram here showing us the point in which the circular frame will begin to break apart and connect with the stairs going up to the porch. And then we have other elements as well, like these spun, almost baluster looking pieces that aren't here really for any other reason than decoration, but they are placed in the location that a corbel or a bracket would normally be located. And that is because with Victorian vernacular, you want to go crazy in the details. This is a style all about going a little bit heavy with ornamentation. However, the ornamentation should abstractly reference structural pieces. So because these components are located at the spot of a corbel, they are referencing the concept of holding something up, even though they're not really doing anything structurally. And then I'm also adding the little extra detail of putting in a circle at the point of rotation for each of these spun baluster components that then connect with the circular frame. Another important detail to note here is how my roof is put together. So this piece in the middle is called the tympanum, and then the frames that hold up the roof tiles, they reference typical classical temple design, where if I were to isolate these guys, you'll see that I have my cyma recta profile going into a little fillet piece and then a fascia beneath. And then I have something similar at the bottom here going straight across, but there is no cyma recta above it. It is just a fascia and then above a fillet. And the end of this fillet should be the rotation point from which the upper trim then rotates to meet its apex, creating a triangular gable. Now, what's very important here is that the fillet for this upper piece does not intersect, it's not flush with the piece underneath it. Instead, this component has its fascia and fillet sort of embedded into the piece below. And you can kind of see that here. This is the proper way to do it. What you don't want is you don't want this. You don't want your upper component to be extruding out above the piece inside. You get a completely different type of roofing design at that point. What I want instead is I want it to seem like my fascia is being almost cut by the fillet of this piece below. And that is the proper way of putting these temple front roofs together. Additionally, I have other elements for decoration, like more corbels. These aren't really needed structurally, but again, we're using decoration and ornamentation to abstractly reference the concept of holding things up. And then because of that, we are drawing attention to the architrave beneath, which is this beam element. And then, of course, the roof above. This extrudes out because of rainfall. So despite the fact that all of this looks quite decorative and ornamented, at the very foundational level, all of these components are referencing typical architectural concepts like support, frames, and then shedding water from your structural elements. So when you are building out these environments in a video game, of course, it's not necessary to use all of these rules 100%, but if you keep these rules in mind, they can actually help you get things done faster, right? Like if you're given a block out and you don't know where to start, a great way is just taking a column, right? Like if you use the rules of diameter to column height ratios, you can very quickly find a column height that can then inform the rest of your design, right? If you know that architraves should go on top of columns, and then on top of that, you get roofs with overhangs, these can all inform your decision-making so that you're not like just staring at reference all the time and trying to figure things out. Additionally, using these rules will begin to make your buildings feel more realistic, which is becoming more and more important in a time when video game graphics are becoming more complex and players are demanding more realistic environments. So, with all this in mind, we're going to move into the next phase of detailing.